Hello and welcome to Learn Elixir Week 4, Module 3. In this video, we're going to go over writing Ecto queries, which allow us to communicate with an SQL database such as Postgres or MySQL. These Ecto queries come from a DSL that Ecto has created for itself that allow us to write syntax that's very similar to Postgres queries themselves, but ultimately it lets us compose them together, which have some long-term benefits such as being able to reuse portions of a query in different queries. Queries in Ecto are actually a bit safer than running direct manual queries with strings embedded into the query. This is because if you have an input that's going into your query, you can have a possible injection attack where someone actually puts a query that's malicious inside of that string input field, say to delete your tables, and you could lose your data or have sensitive data leaked out. This is what Ecto helps prevent because all the input inside of the fields that are going into SQL are being sanitized for those types of attacks. Using Ecto also allows us to eventually have a composable API where we're able to have our functions encapsulating specific features of a query, and that way we can compose our longer queries together using the different encapsulated parts we've created before. Queries allow us to also use where, join, or where, just like they would in Postgres or MySQL. This syntax, it looks very similar to actually writing MySQL itself, and if this syntax isn't enough, we can always drop down into fragments and actually write the SQL manually. Let's look at what this syntax looks like and how we can use it to query our database. For our example, we're going to keep using the same ectoexample.house that we created in the previous video. So we're going to load everything up in IEX, and we'll simply type import ecto.query so that we can start writing queries. We're also going to alias our ectoexample.house as well as repo. And you'll see the syntax here where we're using the same syntax that the shell accepts in order to be able to specify multiple endings. Here we shortened it to separating inside of a curly braces by comma, which allowed us to specify two modules under ectoexample.house. Now with all these things aliased, we can go ahead and start writing our first query. Our first query is just going to replicate what repo.all does. So if we remember with repo.all, we're allowed to specify a specific schema module and get all that queries from the database that schema represents. So in our case, we ask for all of the houses, and we get back all of the houses that are returned by our Postgres query in our debug log. So we can recreate this query by typing in from and then specifying h in house, and that is basically the same as just specifying the schema module itself. So if we actually pass this to repo.all, we'll get back the exact same result. However, because we specified it in from, we're now able to specify a query that looks very similar to SQL syntax itself. So we could specify from h in house where the house price is less than 20. And now we'll only get back one result because we're looking for the house price of less than 20. We can see that our call essentially got converted from our query that we wrote inside of Ecto into a SQL query itself. We can go further into this and create an OR clause where we say OR h.name is equal to test house. And now when we say that, we get both of them back because we're specifying an OR query where the name is test house. We can also separate our OR queries and AND queries out by calling the where or OR multiple times. For example, if we wanted to get AND name, we could just specify another where. And you can see here we did a where price is less than 20, as well as a where the name of that house is test house. And so we got back 0 results. We could specify OR queries by typing in OR where. When we do that, we see that our query gets changed to an OR query. So this is how we can specify queries as individual parts of a whole that get combined together at the end in order to form our final query to our SQL server. This makes it a lot simpler to figure out the logic of a query when we can separate it out by specifying one per clause. With our from query, we're also able to specify a select and can select different fields off of our data. For example, we could say the price, and we'll get just the prices back. We could also specify the name, or we could even specify a map where we specify some key is equal to the house.price. And here we get back our sum key map with the price. We can select any data type we want here, including tuples. So we can actually add in h.price as well as h.id as a tuple, and then when we call that, we get back our tuple response of the ID and the price. Our select query is extremely flexible and allows us to really pull out the data that we want in order to be able to return it. Now that we've seen how to write queries, let's move on to how we can compose them together. We can write our functions inside of our schema modules to keep it a bit cleaner so that our schema has a set of functions that defines the Ecto API that it works with. And so these functions can be a specific part of an Ecto query that we can combine together to make a bigger query. We do this by using the first parameter of our function and keeping it defaulted to the current schema. This, combined with the composable Ecto API, allows us to define a specific query that is able to run on another query that's passed in. If we compose our own functions together, we have a lot less work to do in the long run because we're often doing a set of similar queries in order to be able to get specific parts of our data, but often need that specific part of data while doing another query. In this case, we could have two functions that we could compose together, one function being the filtering and the other being an averaging, where we could use that same filtering functions on different features. So if we didn't want it to average something, we could just return that result by passing it the same first function that did the filtering. Let's take a look at an example of this. As well as the from API, we also have another Ecto API that allows us to specify our queries as individual parts and then compose them together using pipelines. For this example, we actually can pass our queries into each other and start with the first one of just our schema. So we can simply type in house and then specify where, and we could say that we want to find the name of test house. We could also write or where, and here we can pass in a binding, and with our binding we can say that h.price is less than 20, and finally we can also pass in our select, where we say select our binding again, which is our house, the h.id, and the h.price. In this version, we store everything as a different function and can use them to pipe into each other. This means that we can actually store different sections of the query in separate functions and reuse them where applicable. In our example here, we have two versions of a where query. The first one is simply setting an equality check where the name is equal to something, and we can actually do that with a keyword list. However, there are more complicated cases where we still need to be able to write our own code of a comparator function. And so in that case, we can actually create a binding array and say that this is going to be a parameter that's available in the following function. And so we're able to specify a function here for how that query is run while using a field of that data. And so this looks a bit similar to when we write Postgres queries, where we can say from houses as h0, and then we can specify h0.price, h0.name. So this is similar, where we're specifying as h in our or where, and then specifying h.price is less than 20. We can also pipe our select in, which means that eventually we could have a different set of selectors, which we just pipe to the result of some sort of queries. And that's really what allows us to create functions that encapsulate specific features of our API together, because we can essentially pass this house schema in at any point, or we can pass in another schema and it composes it together into a query for us. So we can use this API in order to be able to create our own query functions and compose our own query functions together to group together specific sets of queries. Let's take a look at an example of creating these queries inside of our Ecto schema so that we can keep our code clean across thousands of queries. So we're just going to open our house module and we'll create a by greater than price, and we'll pass in our query as our first parameter, which will just default to the Ecto example.house, which is our current schema, and we'll pass in our price as our second parameter. Here we can use our composable API from Ecto to specify where query and then specify the house binding and say that our house.price is greater than our price. You'll notice that we use this weird little symbol here, and this simply means that we're using a variable that's defined outside of our query's actual scope itself. So the scope of our queries is all defined from within our query functions themselves or within our bindings. So in this case, we have our bindings, which defines what the scope of the variables available to our function here is. And so this function is able to use h because we've defined it in the variables for this specific function. We can't, however, use price without this caret because it's actually not defined inside of our bindings in any way, and so the query doesn't actually know what it is when executing that macro. However, once we add that back, the price is able to completely be used even though the scope is from the outside. So we can also add a case for where it's less than, and we'll just change our G to an L and change our comparison sign to be opposite. We'll have one more case where we define an OR by searched name, and we'll pass in our query again, which will default again to ecto-example.house, and we'll have our name. So we can use a like query to be able to search for a sub piece of text inside of the text of one of our columns. So in SQL, this would normally look just like this, and we would say where h.name like and then our query. And so our query could say anything like hello, and we could put percentages where we want there to be wildcards. So in this case, we would match anything where the hello is in the text at all, or we could specify where it's at the end of the text or at the beginning. So in Ecto, we can stimulate writing this like query by simply using the like function. And so we'll, in this case, do or where since it's an or by, and pass in our query, and then we'll take our binding for our house and pass it into a like where the house name is equal to some sort of name. In this case, we're not actually doing a very good search because it's basically checking for equality. In order to write a query for a like, we actually have to define it outside of our Ecto's query itself. So we'll just define it up here as search query, and then specify that we're searching for anything with a name in it. So that starts with a name, or ends with a name, or really it just has the name inside of it. And we'll change this over to search query. Because it's inside of our DSL's function, we'll have to also interpolate it in using the caret. Now we have an OR by that allows us to search for a name as well using a like statement. We can actually switch this over to iLike so that it's case insensitive as well, and the case of the match doesn't matter at all. The last thing we have to remember to do is import our Ecto query API. So we import ecto.query, which allows us to actually use all of these DSL objects such as where and or where, as well as the iLike. So now we can head over to IEX and check this out. The first thing we'll do is do an alias for ecto-example.house and repo. And so we see the syntax again where we do a multiple alias for one namespace using one line. And so we now have our house and repo aliased. We can do our house and specify by greater than price and pass in a price. And when we do that, we see that we're looking for prices that are greater than 10. We can then pass this to repo.all and get our houses with a price of greater than 10. We could also compose this together and specify that we want houses that are greater than 10, but that we also want houses that are lower than 40. And so now we get a query where we have a house that's greater than 10 as well as a house that's lower than 40. We can then pass this to repo.all and we'll see that we get back no results because nothing matches our case of having a house price greater than 10 but lower than 40. We can try out our last case by doing our house or by search name and passing in a name of test house, or even just test. And with this, we get our iLike query in our or where. So we can then use this and pass it again to repo.all, and we actually get our test house back because even though it didn't match the prices specification of being greater than 10 or less than 40, it did match our or query of having a name that was similar to test, or that had test in it in some way. So using our schema module, we've created a composable API that allows us to define the functions we want to interact with our data and then compose those functions together to create different combinations. So we can do different combinations of these functions and still query them without having to rewrite the base query. And we're also a lot more declarative than when we simply write the query raw. If we wrote the query raw and simply specified where the price is less than this and where the price is greater than this over and over again, it would be harder to read than actually just specifying it in words and then using our words to compose together what our functionality is. It also helps because we can take things out. Say for example we wanted to get rid of the less than price, and we can compose the rest of the functions together still. So this allows us to easily modify our query by simply adding and removing functions. Another cool thing is if we actually look at this query itself, we'll notice that it's actually some sort of data struct. And so this is actually a struct that holds a bunch of information on what we want the query to be, and that query is then read by repo and processed into a database query for us. You'll see this pattern a lot of when you use some sort of data format in order to then pass that piece of data to a different module which composes some sort of functionality with those settings. So in our case, our settings are our query, and our query is stored in a data structure, which is then passed to repo, and repo processes that data structure and turns it into a database query. One thing that's really important to know when you're creating these queries is how to organize them so that you can actually make sure that you're not overwhelming the overhead of figuring out how the queries work or what they do when that time comes you need to dive into them. The way that you can do this and keep this organized is by using your schemas as query storages only. So what they do is literally just store the query and what the query does, and you don't call that query from anywhere other than a context. A context is basically the glue of how we can glue together our queries and compose them to fetch the data. What we want our context layer to be is a layer that just gives back the data and says, I know how to query for this given my parameters. So if you give it the parameters of X, Y, and Z, it gives you that data back with X, Y, and Z and abstracts the entire querying solution away from you. This allows you to only access the contexts in the other parts of your application and really clean up the data flow because you're not worried about how to query that API inside of that specific feature. So if you're building out, say, a feature for a user, you're not worried about how you're querying that user inside of that feature. You're just worried about how you work with that user as a result of our context. Our context essentially allows us to impose a self-limitation of saying that we're not going to access our schema modules directly outside of our contexts, and that allows us to maintain a better level of organization. Contexts are essentially our schema's glue in that way because we're able to just glue together our schema's functions and then make sure that we're using that function to call repo. Let's take a look at an example of converting our house schema into a subschema of a context and using our context to manage it as opposed to calling repo directly. The first step is to create a schema context. And so in our case, we're going to call it properties to signify that we might have multiple tables under our properties. For example, we might have our properties address, or we might have our properties owner. We'll now just move our house over to properties and then make the module ectoexample.properties.house. One thing you'll notice is that our schema context is traditionally pluralized, whereas our schema module is not pluralized. This is just a convention that has come to be in the community of Elixir. So we'll just create our properties context and call that properties.ex and define our module inside of it under ectoexample.properties. In here, we can do our alias for ectoexample and specify our repo as well as specify properties.house. You'll see that we can actually specify a namespace module inside of our multi-alias declaration. And so this allows us to simply alias multiple modules at the same time and also add modules that are under another namespace. In here, we can use some of our composed queries and create some data sources. So we can specify all and then we can take in parameters and specify do and end. So what we could do here is specify that we want to reduce through the parameters, and we want to turn the parameters into a query. So we're just going to pass in our house, and then we're just going to specify that we want to convert field to query too. So what we'll do now is create our convert field to query function, and in our first parameter we're going to have our field, which will say if is price greater than, as well as a value. We're going to take our query and we're going to call house dot by greater than price with our query as well as our value. And so we can actually convert this to house as well, and we can have a price less than and do house is less than price, as well as we can have a name, which we just type or by search named and pass in our query and value. Now we're using reduce to turn our parameters into an actual query itself. Essentially what we're doing is we're saying that the query is our accumulator, and each item is going to be a list or a map of the following keys. And so we'll have a price less than key, a name key, and a price greater than key. And each of these keys adds a new query onto the existing accumulator query that we have in our second parameter, and then it uses that as the query parameter for our next function. So if we had a price less than, our initial query would just be the house that we passed in above here, and we'd specify that we want to pass in the by less than price with our house as well as the value. If we also had a name, the second iteration would pass through our second definition here, and so we would take our value of our name query and then our query, which has the price of less than, and append on an or by search name with our value. So now that we have this all, we can actually pipe this in to repo.all directly. So we can take this and just pass it in to repo.all. Now what we have is we have the ability to fetch all of the properties houses by a specific set of parameters. So this is one way we can clean up our schema modules and keep everything abstracted and have specific filters that do what we want come in as parameters, but then not know anything about the Ecto query syntax or even have specific functions in our context. If we had specific functions, say we wanted to do a buy between price function, we could do that by using a query instead and saying between price. And so we could say between price, where we just have a start and end price, and we can just say that we want to add to our query that we have a house less than the end price as well as greater than the start price. And now we've just created a between price filter that we can accept inside of our all params. Using this type of pattern really helps us keep our code clean, because the outside world only ever has to interact with one function in order to fetch all of the fields. In often cases, we can just pass our GraphQL parameters right into this function and allow the GraphQL types to specify which queries we have are available. So for example, in our GraphQL types, we could specify that only the between price filter was available, and if it was passed in, it would automatically get used here and then converted into our all query, and our properties would just return with our houses. In order to signify that, we actually want to change this to all houses, so that we're specifying that our property is returning all of the houses. This is a convention inside of Elixir and Ecto, is to use this context module and specify the schema name inside of the function's name itself. I have a personal preference for creating these abstracted functions under all, find, or delete and create, and just having a CRUD API exposed through my context for each of our schemas individually. This allows me to use the same API everywhere and to have an expected API of how something will be called. It also allows for a really high level of reusability because we can use the parameters to then compose together our queries instead of having to compose together functions. So in our case here, we're able to combine any of these filters together simply by specifying the values at the same time. So we can go ahead and check this out in IEX, and we can do our alias and just do an alias for properties this time. And we can specify properties dot all houses, and we could say price greater than 10. And now we get all of our prices greater than 10. But we could also say price less than 40. And now we get our houses greater than 10 and less than 40. So this pattern allows us to customize our queries by simply having different parameters. We can also see that if we use the queries such as between price with multiple queries together, it still works as well. We can even combine that with searching by name and specify my, and we get back our query with our I like of my. So this really allows us to combine our queries together just by using different parameters and allowing our reducer function to build the query for us. Using this technique is an incredibly good way of keeping your context clean and not full of different functions to access your schema modules. If you use specific functions every single time you're trying to access something inside of a schema, your context module is going to become a giant cluster of functions that's going to be extremely hard to maintain. What's good about this technique is you can often create the queries you're looking for by existing parameters without having to specify a specific function. If it's not available, you can always add that as another key to your parameters, and then you'll be able to use that in the future as well. Now that we know a bit about how we can use queries and compose them together using a context module to keep things clean, let's move on to the next video, and I'll see you in the next module.